Good afternoon, dear authors and invited guests. It is my pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT 2021 Global Knowledge Research Foundation. As every one of us is passing through unseen circumstances due to COVID-19, we wish everyone and their families a safe time, and we all hope to pass through this together soon. Further, with immense happiness, I'd like to share that we have received an overwhelming response this year from across 90 countries, where 1,000 papers were received and 350 papers were accepted, contributing to the success of this conference, and the papers we will publish in 4 volumes this year. We are thankful to our guests present on this platform to join us digitally for this conference in these unpredictable times and make these conferences more fruitful in terms of technical knowledge, and hope you enjoyed the last day of the fruit of the knowledgeful and interactive sessions. I'd like to welcome you to the technical session 5 and further introduce you to the chair of this session. Jose Quanum. Jose G. Quanum received his degree in computer science from the National University of Benin in 1996 and a master's degree in computer science from Paris Dauphine University in 2002 and a PhD degree in computer science from University Pierre and Marie Curie in 2005. He is currently an associate professor at the Namibia University of Science and Technology. His research interests include multi-agent coordination, software architecture, distributed systems, big data infrastructure, and artificial intelligence. Jose, welcome. Can you hear me, Jose?
I was muted.
Yeah, welcome to the chair.
Thank you. And thanks everyone for joining. My name is Jose Quenam, and I'd like to welcome the presenters for this session, the track 5 on technology computation. We'll have 7 papers, and for each presentation, we'll have a total of 15 minutes, 12 minutes for presentation, roughly, and to allow about 3 minutes for questions. So let's allow the first presenter on blockchain as a technology contributor, a survey, Khurram Mahmood. Could you please share your screen and get ready so we can start by 11:30 sharp, please. Hello, Mahmoud, are you there?
I don't think he's here, so should we go on to
Khurram?
the next one?
Yeah, okay, we can do that. Is Farad? Oh, is Farad there?
Yes, I'm here.
Okay, are you ready to present?
Yes, I am ready. I hope my 2 other colleagues are there. So yes, for sure, I'm going to present if you want.
Okay, so since Khurram is not there, Khurram Mahmoud is not there for the first paper, we'll jump you up, we'll jump that presentation and move to the next one.
Sure.
So you will be the first presenter.
All right, should I
in
share?
the meantime, you can share your screen, please.
Okay. Can you see that?
Yes.
Yes.
Okay. Should I start?
You can wait for 11:30 sharp to start.
All right. Okay.
Just to allow time for 1 or 2.
Yeah, I'm in Sydney, and we are 10:29 p.m. So we are about 11 hours ahead of you. So
yeah, I'm in Windhoek, and it's midday actually.
Wow.
That's why I'm careful. I'm careful about how I say the time.
Right.
Because I have to stick to the official.
Okay.
Okay. I think we can start now.
All right.
Please go ahead.
Thank you, sir. And
so we'll have about 15 minutes. Please go ahead.
Sure. Good morning, London. Good day everywhere else. And thank you for attending our presentation, which is about evaluating challenges in using big data in healthcare applications. Without any delays, I go to the opportunity statement. We decided to have opportunity statement rather than problem statement because it is all about opportunity to grab. So we believe that effective utilization of big data in healthcare applications will further decrease medical expenses, will help forecasting outbursts of epidemics, will circumvent preventable illnesses, and will enhance the overall quality of life. These benefits have already been realized, but we believe that effective utilization has more opportunities to the organizations. Our objective, well, this is a work in progress. So we have a long-term objective. The long-term objective is to use the result of this study to guide the design of effective user interface for healthcare big data applications. For this particular study, as a step one of the project, we are going to identify and evaluate various existing challenges associated with the use of big data in healthcare applications. Actually, in the next 3 slides, I'm going to talk briefly about current state or aspects of big data in healthcare, and then before we start our methodology. So the sources of data in healthcare applications, plenty of them. The data could come from machines, such as sensors, wearables, intelligent meters, and so on. They are biometric data acquired from physical features of the people, heart rate, blood pressure, X-rays, and so on. Then we have data coming or produced by humans. These include case documents, lab outcomes, hospital admittance, and all those things plus the emails. Number 4 source of data in healthcare applications is transactional data. We used to call it the structured data. These days, they like the term organized data. These are the data that are used by accountants, typical structured financial, numeric, textual data, which is part of the healthcare application data. Then we have epidemiological data that include important statistical data, data from health surveys, and registration of diseases. And finally, the most traditional source of data for healthcare applications, publication data. That includes information from medical studies and clinical reference data. The other aspect of big data health applications is the nature of the data in these applications. These are the 5 generic characteristics or attributes of big data, and they all apply to healthcare data of today. Look at the volume. Huge and persistent amount of data are sourced from various sources, as I mentioned. High speed of generation of the data, distribution of data, and collection of data, all in real time. That is a typical health application of today. Or the type of data that use high speed, data, type of application that use high speed data. Variety, data collected from various sources, and they are very heterogeneous, and they are not very easy to put them together in a single application and generate intelligent reports as we expect to. Veracity, that refers to the quality of the data being collected. However, when it comes to healthcare applications, it's not just about the quality of data itself, but also the trustworthiness of the data source, the trustworthiness of the processing of the data, and many others. In terms of value, it's quite obvious that big data in healthcare can potentially produce massive amount of data. So that is the nature of data in today's healthcare applications, which is actually attributes of big data. In terms of analyzing of these data, there are three generic applications or data analysis, and each generic type has got hundreds, if not, dozens of subcategories. So first one is forecasting disease and infection outbreaks. The second generic type of analysis is intensifying treatment and standard of living and avoiding the spread of diseases. And of course, all these are happening very rapidly in real time, and especially as a result of the countries shifting towards EHR, or electronic health record. If you probably know that right now, many of us can go to any part of the world with any doctor, and our entire health data will be available to those professionals and hospitals. So that is these are the three aspects of the health data, health application. Let's look at our research methodology. First, the goal of the study is to identify, classify, and evaluate various challenges that healthcare organizations are facing in relation to the big data, in particular in relation to the big data. The sources of data for our research mainly are relevant research and industry publications. The method of analysis, we are using 6-step thematic analysis that I briefly explain in the next slides. In steps 1 and 2, existing relevant work were reviewed and coded. So to be systematic, to be scientific, we used hermeneutic circle for search and selection of these papers. Then for each paper, a list of codes was identified progressively. And as the study proceeded through the next 4 steps, we added more and more codes to the major pool of codes. And at some stage, we came to a point where addition of another paper did not really contribute any more to the existing pool, and the codes seemed to be repeating. So that was a signal to us to stop reviewing. Now, that is what happened. At step 3 of this, under this method, we created the themes. Well, themes are contextually meaningful categories of identified codes. That was a big challenge for us to do it, especially that we have to, in conjunction with step 5, the final definitions of the themes and naming them. We had to be very careful. That is part of our evaluation, to be careful that the themes are not, we are not just adding to the current jargon, which we have enough of it. In fact, we have too much of it. We just made sure that our themes correspond or matches with existing themes in the literature. So that was another interesting thing that we decided, we attempted to do. In step 6, we evaluate the results of thematic analysis and justify the results. So I show you our codes, just a sample of them. In this left-hand side column, you will see the papers. We just stopped at this one. For each paper, we identified 1, 2, 3, 1 or more codes. Many of them are repeated, but each paper had something new to add to the pool. So eventually, we came to a point where the codes were not repeating themselves, so we stopped that. So that was the space that we reviewed, or we targeted the literature. In terms of, in terms of thematic analysis, I just make it larger. Sorry, I cannot, yeah, okay. In terms of thematization of the results, that is what we did. As I said, we used standard themes that are currently used. And for each theme, we have, as you can see, these are the codes corresponding to each theme. So we present our results in terms of these themes. Now, what is our results? So I'm gonna, as the last part of our presentation, I explain to you results of our study. We identified several challenges. The first one is the challenge of capturing and storing large amount of information. That was a big challenge. Were cited in many of the papers that we reviewed. And that large amount itself is exponentially growing. So you can imagine where we are heading. Next, security and privacy issues. Again, being health data above everything else, ethics, and so on. These will some of the issues that we identified in the literature. The third challenge was maintaining quality of health and lacking a health-specific, sorry, it's a bit of mistake here, maintaining the quality of the data and lacking a health-specific standard for handling the data. That is very true. We did our best to as much as I could, but it is a challenge. Organizational challenges, plenty of them. Some of them include requirement of big data infrastructures for some hospitals, boosting analytical and application capacity of the organization, and additional managerial tasks, and so on. Challenges related to medical images. This is specifically those of you who are familiar with image processing. You would know that how difficult it is to do the pre-processing of these images when the images come from the X-rays and other type of pictures or images. So that's a big challenge as explained by many. Next, integration of heterogeneous data sources. That is classical problem with any big data application. Scalability of the data. We can actually kind of forget about centralized databases at the time. That has been one of the biggest problem. And as you know, hospitals tend to have, they favor more centralized databases for various reasons. Time criticality of healthcare applications. That was the big challenge. And data science, training and variation of workforce. And finally, support. These are the challenges that we identified, and and thank you very much for listening, and please ask any questions.
Thank you for your presentation. Are there any questions in the room? Any questions? Okay, mine is not a question, it's just a quick comment. So of all the challenges that you identified, say for example, one wants to address.
Sorry, you are saying that what's the major challenge out of all these? Is that what you're saying?
No, I interrupted my question because I saw a message from the chat. I thought it was a question. Okay. I was just saying, if one wants to address the technical challenges, like, you know, the storage capability and the computation, how do you suggest one goes about it? But knowing that, you know, different places will have different culture of handling these challenges.
That's very, very good question. Thank you for that. You see, the main idea here is to guide the design of human user interfaces that caters for all type of viewers or users, regardless of culture. Of course, culture is a big part of the user interface design. So that is the challenge itself. What you just said is a big challenge. However, we believe that designing those things that you just mentioned or fixing the problem that you just mentioned would require to fully understand the challenges first. So we kind of prepared these challenges in a reliable number of challenges. And in terms of technical problems, of course, that would be, the tendency these days is not for the user to worry about it. It is let the SAP and other companies worry about it. That's what I think is the trend is towards going.
Okay.
I'm not sure if I answered your question.
I mean, you at least you've given your perspective. Like you said, we'll never have a total agreement on that point. Yeah. Thank you.
Yeah. Thank you.
I think we'll move on to the next presentation. I can see that Kuram Mahmood is back in the room. Are you ready to present? We skipped you because you were not there when we started. Are you ready to present?
Yes, I'm ready. Should I?
Could you please share your screen?
Should I? Okay, thank you.
So your presentation will be about 15 minutes in total.
Okay.
Including the questions.
Okay, this is Khurram Mahmood from Pakistan. I'm going to present you a paper on blockchain as a technology contributor. It's a survey paper. It's abstract. Blockchain is a technology that is initially used for cryptocurrency, like a Bitcoin. The biggest advantage of this technology is that it is immutable data stored in block cannot be changed. Rather, new block is added in the chain and new record can be inserted into it. The previous record shall remain same and the record of every transaction can be tracked. Many studies and surveys have done on blockchain mentioning the implications and contribution of blockchain. The main purpose of this paper has presented a detailed survey of blockchain mentioning its feature, advantages, and protocols. In this paper, we are presented the working features and usage of blockchain technology and the future work, which will be based on the cloud computing and Internet of Things. Blockchain has emerged as a new technology at the beginning of this millennium and gained significant importance during the past few years. It replaced many current digital platforms. Blockchain is based on distributed databases that are highly encrypted in order to prevent fraud in and enter record. Financial institutions maintain financial records, hospitals maintain medical records, universities are maintaining their own educational record, and so on. The main characteristic of this technology is decentralization. The decentralization is the major feature of blockchain. That means the blockchain does not rely on centralized architecture. All data can be recorded, stored, and updated in a distributed way. The data record on blockchain cannot be fraudulently changed, thus it ensures transparency. It is an open source technology. People can use it field to develop new applications, can check their record and can easily store their data. Blockchain work with full autonomy in a way that every node can independently transfer and update data without any intervention. No record can be altered in blockchain nodes once it's safe unless someone can take control of more than 51% of the node. So it is immutable. This is the structure of the blockchain. If you see that in the first structure, we have head of current block and head of the previous block, timestamp, other information, and the main data. When we are going to add the new block, the same data will consisting of the other block, but we are incrementing the number of which are belongs to the number of current block, the head of the previous block, timestamp will be on the new one, other information, and so on. The data will be added into the this structure of the blockchain. The advantages of the blockchain technology is reliability, security, efficiency, and trust. The application developed on the blockchain are highly reliable because single point of failure does not affect the whole application. It converts whole decentralized record into the centralized way without affecting its architecture. Only the trusted institutions can access the decentralized ledger. Blockchain is trusted because its ledgers are distributed among tamper-proof nodes. Blockchain networks use one-way mathematical hash function as input that has variable length and its output has no reflection of input. So it is slightly secure technology. This technology is highly efficient because it runs through preset procedure. So it reduces the cost of the labor and increases efficiency and promotes automation. The main challenges of this technology is a selection of an appropriate and strong cryptographic hash function that is robust and fault tolerant so that no one can break it. Correct design and implementation of code, selection of robust and efficient algorithm. The protocol of which are the protocol that this technology are going to use, which are proof of work. Proof of work is a protocol that is involved in performing extensive data mining calculations and transactions so that a new block can be formed in blockchain. The next one is the proof of stake. Proof of stake protocol allows to mine validate the block that is created through the proof of work. Practical Byzantine fault tolerance ensure the secure communication among the two nodes, even if they have the same data. This is the future discussion. Currently, there are many security issues which cloud computing is facing, like security, confidentiality, transparency, etc. When cloud computing is integrated with Internet of Things it become cloud of things and the security concerns increased. In order to enhance security and ensure confidentiality and transparency, the author uh, will implement a blockchain, the blockchain of cloud things. This not only will enhance security of system, but also ensures transparency in every transaction. For the implementation of this framework, no new protocol will be developed because the already defined protocols of blockchain are fulfilling the need of its implementation. The conclusion of this blockchain technology as a contributor, the concept of blockchain has moved beyond its usage. In Bitcoin, it can be adopted in many other areas as well. Blockchain transactions are used in both communications, whether they are human or to human or machine to machine. Blockchain is especially meant to be applied in deploying countries where trust and security is a major issues. In this paper, emergence, benefit, and challenges related to blockchain are highlighted along with the future dimensions which can be helpful in future futuristic implementation. This paper has well defined that how uniquely we will use blockchain as technology contributor. Thank you very much. If you have any questions, please you can ask me.
Thank you for your presentation. Are there any questions in the room, please? Any questions? Okay, just a quick question for you, Kuram. Could you
are you listening?
can you hear me? Can you hear me? Hello, can you hear me? Hello, Kuram, can you hear me?
Yes, we can hear you, Kuram.
Hello.
Yes,
Yes,
it's
please.
audible.
All right. So I was just trying to ask a question.
Yes, please.
Could you please tell us about the challenges in implementing a blockchain solution?
The main challenge is to design an application which can give you the transparency, efficiency, and confidentiality at the same platform. The major problem in this technology is to provide a proper hash solution which will give you the complete this triple it model at the same application level.
Okay, and if you were to compare existing implementations, like instead of us re-implementing the theory of a blockchain, if we want to grab an existing solution like Ethereum, for example, could
yes,
you give us a quick comparison?
as I already said you that the blockchain technology is basically emerged from the Bitcoin or cryptocurrency technology, but as a new technology, most of the people or authors are working on it in different scenarios, like in education sector. The education records are very important, which needs to be a very secure, and integrity of the data have to maintain, so we can not afford to change the result of any student without knowing the university people. So we can implement this technology in the university, in the hospitals, in banking system as well.
Okay. Actually, I was asking about the actual existing implementations like Ethereum and a quick comparison between them, see whether efficient, whether not.
The system is very efficient, of course, because but the main advantage of this system is to provide the data integrity. You cannot change any data or delete any data from the and all the data all the records are as be saved with the timestamp. You cannot delete anything or without knowing to the concerned authorities. So I think it will be implemented in the banking system or in the hospital system and in the university system where you can implement this.
All right, thank you. I think we'll move to the next presentation if there are no further questions. Are there any other question? See the chat. Right. So the next paper is which features are helpful, the antecedent of user satisfaction and net benefits of a learning management system, by Bernie Fabito. Bernie, are you there? Can you please share your screen?
Yeah. Hello. Hi. Are you able to hear me? Am I audible?
Yes, I can hear.
All right.
Yes, I can
Let me just share my screen.
Okay.
For a minute. Let me just fix my monitor right there. Oh, wait. Okay. Sharing. All right. Are you able to see my screen?
Yes, I can see.
All right. Okay. Thank you. Well, here in the Philippines, good evening and good day to everyone. The paper is entitled "Which Features Are Helpful: The Antecedents of User Satisfaction and Net Benefits of a Learning Management System." So I am Bernie Fabita, and together with me are the following: Miko, Jessica, Jelsa, and Shane and Nicole. So LMS, the implementation of LMS or the learning management systems, it has grown exponentially in terms of its use. Here in the Philippines, although not all are using learning management systems, but due to its flexibility when it comes to providing or what's this? Flexibility of providing instruction to the students, most HEIs or higher education institutions are now using learning management systems, but basically it would entail cost. This growth has intensified primarily because of the COVID-19 pandemic. Most schools are now using learning management systems, although they were not really using learning management system before. In one day, they had to shift immediately to learning management system, which caused problems not just with the faculty members, but as well to the students. Although although there are a lot of studies, there are a plethora of literature that basically talks about what makes or what are the success factors of learning management systems. What makes it different from this study is that it tried to look at the features of LMS that can contribute to the information system's success. In the literature, we have the implementation of the information system success model, though although there are other types of theories. But what we decided to make use is the ISM primarily because it really talks about information system success. Now there are a lot of studies, as I have mentioned. We have from way back 2014, 2019, and it talks also about external variables, but does not really look at the features of LMS as a predictor for information success. Hence, the study is basically about trying to understand or trying to look at the features of LMS that can somehow predict the intention of an individual to use a learning management system. So the study was piloted in a private higher education institution in Manila. This was conducted for faculty members. So this was administered to the faculty members, but this was during or before or prior the COVID-19. This was conducted, or the survey was conducted way back around, if I'm not mistaken, August, November, December of 2019. And the lockdown came here in the Philippines around March. The lockdown for most cities came about around March. Okay, so they were not able to fully realize or be able to fully take a glimpse of the full feature of the learning management systems. The ideas came from the blended learning type. It's using that additional type of learning with the learning management system, so it's not a full-blown learning management system. All right. So the features since I've mentioned, well, what we wanted to do is to look at the features of LMS and how it affects the different information system constructs. So these are the different features, although there are a lot more, but we got this from one literature. So it includes chat support, course creation, assignment submission, assessment quiz, message boards, collaboration, mobile integration, gamification, video conferencing. And there was one study that says that the features of a learning management system can be divided into four. So this was a study of Jurado, Peterson, way back in 2013. It was classified it was grouped into four categories. You have the tools for distribution, communication, interaction, and course administration. So what we did was, given the different features, we grouped them based on how Juardo et al. Grouped the features of learning management system. So we did so this is the research framework using the four groups categories of a learning management system and how it affects the three categories of the information system success factors. You have system use, user satisfaction, and the net benefits. Now, looking at the demographics of how useful the different features are. Again, this was administered prior the lockdown, so we were basically using the blended type of learning. So you have the traditional and you have the learning management system. So looking at it, most define chat support as very helpful as 51%. Video conferencing is 17.53. Saying that somewhat helpful, and you have really and not that helpful around 36. Again, simply because the survey was conducted prior to the lockdown. But again, as I have mentioned, we're now using online learning. Currently, we are not allowed to conduct face-to-face sessions. So most of the learnings are done through online sessions. And using a Spearman correlation, so we were able to see a very slight or weak to moderate relationship between the different compositions, distribution, communication, interaction, course administration between the three success variables. You have system use, user satisfaction, that benefits. Although what is, I guess, the highest is the communication side. This is faculty members, since we are using blended learning before, they kind of somehow the communication part of the learning management system is what makes what's this or could somehow there's a relationship between system use, user satisfaction, and benefits, whereas the others would have like weak a correlation, and yeah, we have weak what's this correlation. Now we did some validation, but this validation now comes with the students to check whether feel the same way, they feel what the faculty members feel as well when it comes to the use of the LMS. So they mentioned using an FGD. LMS serves as a medium for communication. So instead of using social media accounts to communicate with their faculty members, to communicate with their peers using LMS, they can easily get the attention, or they can easily connect or communicate with their again faculty members, or what's this a peers or classmates. So LMS serves as a tool or a medium for communication for them. So it kind of bridge the gap between the faculty and the students. And for the limitations, since the study made use of correlation, we were not able to do we were not able to somehow sorry it does not reflect the cause and effect. We were not able to do regression simply because of the nature of data that we have. But the future endeavors would require probably identifying how it is now in the current situation versus the result that we had. Like, for example, video conferencing, is it still that as much? And probably look at the other features of LMS, and how it can influence the various the other variables under the ISSM. So yeah, so that's it. Thank you. Thank you for listening. Right.
Thank you, Bernie. Are there any questions in the room?
Where's the all right, stop share.
Any questions? Okay, Bernie, let me ask you a quick question here. I like a comment you made during the presentation that although we're using these learning management systems, we're still teaching the old way, more or less. And I will assume that the purpose of moving to a digital learning environment is to be able to deliver education, as I like to say it, to what is tailor-made for specific people. What I mean by that is that if you take a group of learners, each one has got the specific issues that you should address in the learning process. how do you think, or what do you think are the limitations of the current learning systems with regards to that point? And how do you think we could address them?
All right. Thank you for the question. Yes, as you have mentioned, there are a lot of barriers actually. Like here in the Philippines, well, the Philippines is a third world country. Not all students have access to devices. Like as mentioned, we're using it's an abrupt transition from the traditional to an online learning. And as I have mentioned, we were not really prepared. There are students who are working in provinces who are studying in provinces. So these are far from the cities. And these provinces these are the students who have difficulty getting stable connection, their internet connection. Now, or aside just from the internet connection, they don't have say laptops. Not all have laptops. Not all has a good say tablet with bigger screens. They don't have that a luxury to what's this to use. I guess one of the ways that we can work on, like for example, here in our university, we're adapting the so-called synchronous asynchronous learning in such a way that everything is not done online. There will be times wherein we can say deliver the lessons that are recorded, and probably the students, if they would be able to get a chance, if they will have a chance to download the file and at least download the file and store it probably in their mobile phones or at least in their mobile phones using a very small amount of data or say file size, at least they will be able to follow. So we're trying to look at some steps on how these discrepancies or what we call the digital divide here in the Philippines to address these issues. Another is that instead of using online learning, what we can do is download or store all these learning materials in a say a flash drive, for example, on a compact disk, and deliver it to them. And probably if they have, I guess, a laptop, they can check on that, and then once they're done, it would include an assessment, and they can simply mail that back here again in the city. So these are just some, but yes, there are really problems when it comes to the delivery of online learning. As I have mentioned, we are a third world country, and not everyone basically has access to the internet, including the devices. And our students are quite diverse. It's not all are would have the capacity to buy these devices. Unlike before, it's a traditional. They can basically come to school and participate to the instruction.
Yeah, yes, I get all those points, but the specific point I was trying to make is that uh, it's not really the issue here. Is not really on the learners part, but you can see that in a way those learning management tools still fail to deliver on the promise that if you the promise of the personalized learning is not there.
All right,
Like I
I would
said,
agree.
if you take a
I
group of
agree.
if you take a group of learners, each one has got the limitations. Each one has got a gap that you need to
I agree.
fulfill.
I agree. All right.
Okay.
Like I guess primarily because learners have different styles, and these styles may not be what's this provided by LMS. So yes, but if you are going to, are you asking if how can this be addressed?
Any if you have any idea, any thoughts that you would like to share with us?
Well, based on my experience, well, I do understand that there are various learning styles. um we haven't reached that a what's this a point wherein actually studied, like, yeah, I just realized that by what you said, that these people have different learning styles, and can an LMS actually address all these different problems. What we are currently facing right now is simply to be able to make sure that these students would still be able to join classes. We haven't reached that thought of trying to identify. Yeah, we understand that there are different ways of how there are visual learners, there are different auditory learners. We haven't gotten that period yet, simply because, as I've mentioned, we are still on the level of trying to figure out like how can we combine these students or pull these students to be able to, continue their studies. Probably, I guess we can now could now go to that level on our side to check on how it can be addressed. But to answer the question, do I have an idea? None that I can think of.
Okay. All right. Thank you very much.
All right.
So we'll move on to the next paper. It's conceptualizing factors that influence learners' intention to adopt ICT for learning in rural schools in developing countries by Sipe Mplana. Did I say your name right? Is Sipe there? Mplana, you there?
Yes, I'm here. I'm here. Can you
Alright.
hear me?
Did I say, yes, did I say your name right?
I'm even
No.
surprised. Yes, you did well.
All right. So can you please share the screen?
Sipemhlana. Are you able to see my screen?
Yes, I can.
Okay, thanks. Good afternoon. It's afternoon this side of the country. My name is Sipemhlana. I'm going to present conceptualizing factors that influence learners' intention to adopt ICT for learning in rural areas in developing countries. This is just a layout of my presentation, which is introduction, research aim, research questions, literature review, research methodology, theoretical framework, conceptual framework, findings and conclusion. The study was undertaken as a systematical literature review. Introduction. Teaching and learning has evolved from approaches that are classroom based and teacher centered to approaches that are learner centered. In the traditional or in the olden days, the traditional way of teaching, it was only based in class, where the student was supposed to attend the class at a certain time, at a certain room. But in nowadays, the teaching and learning is been changed a lot. The students are no longer limited, or the learners are no longer limited with the classroom, with the space, are no longer limited when it comes to time. They can study anytime. They can communicate with their teachers, with their peers at any time of the day because of the ICT that was introduced in school. The migration to learner-centered approach has been facilitated by the adoption of technologies. In the olden days, they were not using these technologies to facilitate the learning. It was only based on the presence of the teacher. The teacher must go and stand in front of the teacher of the learners and deliver deliver the information. But nowadays, wherever you go, the learners are able to start because the approach was changed from teacher-centered now is learner-centered because of the adoption of the technologies. The technologies which include in teaching and learning include communication devices, computers, teaching and learning, software application, social media. This part of the country, the southern part of Africa, the universities and the primary schools are starting to move towards the use of social media, where the tutor and the QT, they use Facebook or Twitter or WhatsApp to communicate. When the QT have a problem, is able to communicate with the tutor using the social networks like Facebook. So they are starting to use social medias as a part of the teaching technologies. The adoption of ICT technologies in the learning have immensely contributed to online teaching and learning as intervention for breaking the disruption brought by COVID-19 pandemic. More especially in the developing countries, now since we are facing this pandemic, it was not easy, more especially around last year, 2020, the schools were closed and the learners from rural areas were unable to continue with their studies because of the technologies. Because to be honest, in the developing countries, their schools are still lagging behind when it comes to technology. The technology are not they are not introduced well or well adopted in schools. So during this time of COVID-19, it was difficult for the student to continue their studies because there are some certain areas where they are still using the olden method, not because they are not capable of using the technologies, because there is no enough resources to buy and use those technologies for learning. The aim of this study is to investigate factors that influence learner intention to adopt ICT for learning in developing countries. The research, the systematic literature review was sorting to find answers from the review for the following research questions. What are the factors that influence learner intention to adopt ICT in rural secondary schools? What are the benefits of adopting ICT as a tool for learning? What are the challenges in adopting ICT in developing countries? Which theories inform the adoption for adoption of ICT for learning? The literature review, even though I didn't put the references here, but when you go through the paper, you'll find the references. It says, despite the positive contribution of ICT to learning outcome in education, its adoption, integration, and the use remain a challenge for rural school learners in developing countries. Even though when you compare the developing country and the developed country, you find out the introduction of ICT in education, it shows some positive outcomes. It changed the quality of education, the performance of the student, but when it comes to rural area schools in the developing countries, you find a lot of challenges that the students are still experiencing when it comes to adoption and integration of ICT. Apart from the pros and the cons, the existing literature is silent on the actual ICT technology adoption by rural learners in developing countries. As I was going through the literature, I find a lot of exciting papers, but most of the research was conducted looking in the perspective of the teachers, how the teachers integrate ICT and use ICT for teaching. But when it comes to learners, more especially in developing countries, there were a lot of informational research that was missing there. Learners from rural areas in the developing countries, it seems like they were left behind when it comes to introduction of ICT in education. It can be interfered that ICT technology adoption at school exclude learners even though they are fundamental stakeholders. As I think I mentioned that one. If learners are excluded from the adoption equation at school, this contradicts the basic definition of adoption, which says adoption is defined as a judgment or a choice that individuals make every time they want to take part in the innovation project. So in other words, if the school only focus in the adoption, looking in the perspective of teachers, leaving behind the learners who are also stakeholders when it comes to teaching and learning, we miss the important part where it says adoption is a judgment or a choice. So in other words, the student or the learners must have, must take must take a choice that they want to adopt or they want to reject an ICT as a tool for learning. Okay, research method or research methodology. In this study, you adopted the Lang and Phil systematic review protocol and the reporting approach by using Alnia and the other researchers in their studies, where it says you start by identifying the research articles, which we check all the databases, all the research papers that were published in the conferences, in the journals, and we come up with search terms from the search terms that were constructed from the research questions. We identify the data source. We came up with the inclusion and exclusion criteria. And after the criteria, after inclusion and exclusion criteria was set, we came up with all the papers that were published in the peer review conference and journal, all the papers that were written in English, and all those papers that were selected for this study. We came up with a classification and the coding framework where we classify them according to the context, focus, method, area, theory, and factors. Okay, I'm not going to waste my time on that one. Okay, this study is underpinned with the theories which help the researcher to explain the adoption of ICT as a tool of learning, which is technology accepted model, theory of reason action, theory of planned behavior, a unified theory of acceptance, and the use of technology, diffusion of innovation. These theories are the one that underpin this research. The theoretical framework lead us to the conceptual framework of the study. And this is the continuation. The study is just the first part of the study. In a long run, we are going to come up with some results. Now, this one is just the conceptual framework that is informing the study. Findings. Some of the findings reveal the key factors as ICT infrastructure, more especially in developing countries where we don't have much internet. Not everyone have an access to internet. Not everyone have an access to a computer or a laptop. It was even worse now during the time of COVID-19, where some of the students were just left behind. So in other words, those who don't have laptops at home, those who can't use laptops, or those who can't connect to the internet, they were unable to continue with their studies. Technical support was also one of the findings, and access to resources and social influence. Infrastructure was found to have a direct obstruction and negative consequences on the adoption of ICT technologies in learning. So in other words, the learners, before they can even adopt the ICT as a tool of learning, the school supposed to come and put infrastructure in the school premises so the student will be able to use those ICT tools. So at a later run, when they feel like it is useful for them to use those ICT for learning, or it is easy for them to use ICT to find information that will help or assist them to learn more about their modules, it will be easy for them to adopt ICT as a tool. So the results that will be found in this study at a later stage will help educational policy strategies when they are providing rural schools with infrastructure and resources. They will know exactly what is lacking, what needs to be done, so that the student would be able to use all those tools for learning. In conclusion, the paper uncovered.
Okay.
Yes, I'm
I
just
just
concluding.
wanted to ask you to wrap up. But
Yes, I'm just a minute. The paper uncover a literature review that's focused on ICT technology by rural areas in developing countries. Even though literature reported an initial undertaking to introduce ICT technologies for learning at rural areas, the adoption of such technology is discussed from the point of view of management and the school teachers. So there is no much information about the learners. Thank you. Any question? Yes, yeah, thank you.
thank you very much for your presentation. Are there any questions in the room? A quick one, since we're really behind time.
Okay, sorry.
Is there any question, any quick question in the room? Okay, I think in the interest of time, I'll just move on to the next presentation.
Okay.
So the next paper, yeah, thank you. The next paper is the practice of tech debt assessment and management with Petra by Sergey Terekov. Sergey, are you there?
Hello, can you hear me?
Yes, I can hear you. Can you please share your screen?
Just a moment. Can you see my screen? Hello?
I can only see S.
We can hear you, but we can't see your screen.
Can you see my screen? Yes?
We can only see S.
Just a moment. Just a moment. Can you see my screen?
Yes.
Hello? Yes?
Yes, we can see your screen now.
Presentation. Do you see my presentation?
Yes, we can see it.
Okay. Hello, everybody. My name is Sergey. I am head of the Quality Assurance Department in Antetics, and today I would like to talk about our technical debt reduction platform and share our experience of using it to assess the quality of software products. We often ask ourselves what is quality. As we know, there are different definitions of software quality. Some define quality as the level of customer satisfaction. Others say it's about meeting the requirements of the customer. For the technical world, it's the state of software being free from defects. At Antetics, we decided to fix that misunderstanding by intensive research of what is quality of a software product and how we can manage it efficiently. As a result, we came to the conclusion that the quality of a software product is the amount of various technical debts embedded into the product and delivered to end users, which is measured by business critical metrics. Industry best practices state that technical debt is any code added now that will take more work to fix at a later time, usually with the purpose of achieving rapid gains. So technical debt is the additional cost that arises from the actions of technical teams to save time or money in the earlier stages of software development. These actions usually include issues in the source code, development environment, documentation, and third-party software. Since such issues make the code hard to change, they need to be refactored in time. If not addressed in time, technical debt will keep building up, gradually destroying the software product. The source code is really one of the most important things in the software. We understand that the more problems are in the source code, the more development is required. However, dealing with this for many years, we started thinking about technical debt in a different way. We have come to conclusion that technical debt is a combined product non-compliance with technical guidelines and business objectives that negatively impact business results. Now, I would like to go into more details about that. Technical debt can be divided on some categories depending on intent and level of neglect. There are 3 categories based on intent. Intentional technical debt arises from business considerations. For example, when a team wants to achieve certain business goals and intentionally makes certain acceptable trade-offs. Unavoidable technical debt is caused by external factors. For example, when third-party system is upgraded and you need to adapt your software to this upgrade. Unintentional technical debt arises from negligence. It often occurs when many developers work on the same solution and one error layers over another. As stated above, technical debt is present, by the level of neglect. Experts also divided technical debt into categories based on the level of neglect. The eventually repaired technical debt is paid on a daily basis, so it will never grow to a noticeable level. These daily repayments are so low that they are highly noticeable. The sustainable debt stays on the same level since it's monitored and regularly repaired. The interest of sustainable debt is noticeable, but it doesn't impact other processes. The complex technical debt appears when a team stops refactoring. It grows exponentially when new features are delivered. And finally, based on the course, we can distinguish about 13 technical debt types, such as automational technical debt, people debt, requirements, documentation, software design debt, and more. As stated above, technical debt is present in almost every software product due to the natural reasons as an inevitable part of teamwork. And therefore, technical debt management has both practical and academic sense. However, no solid theory of technical debt identification and management is built yet. Nevertheless, technical debt is managed practically even if developers don't regard it as a separate entity. From this point of view, we paid attention to the practice of technical debt management, described it as an empirical process, and developed a platform for technical debt management. We called this platform Tetra. So we have developed the technical debt reduction platform as a consultative service for in-depth audit and assessment of software products in order to assess quality level, measure technical debts, and evaluate product efficiency for business. Tetra consists of 8 dimensions. There are source code quality assessment, usability, UI, and documentation evaluation, then security, performance, business logic assessment, and finally, architecture, data quality, and open source code use evaluation. We consider these dimensions as the primary for stakeholders because they have sufficient impact on business needs. Also, such dimensions can be assessed independently when some of them are necessary for certain types of software products. Each dimension is defined and measured by a corresponding set of metrics. The results of all measurements are used to evaluate technical debt presence and its possible impact on each dimension. I am going to show you an example of the Tetra assessment approach based on the first dimension, the source code quality assessment. We focus on the following most critical for the code quality metrics described on this slide. There are cyclomatic complexity, duplications, code coverage, rules compliance, and SQL index. We understand that we cannot improve what we don't measure. If our team didn't collect code metrics from projects, their code base would get worse and worse without anyone ever noticing. We would only notice when the technical debt reached a certain level when it was too expensive to address it. Therefore, collecting code metrics continuously gives our team the advantage of keeping the technical debt of our code under control. To measure these metrics, we use the SonarQube tool and additional created plugins. Now, some words about the advantages of the Tetra assessment approach. sorry, it will be, I think, the next slide, but now some words about a report that we provide for this assessment. I would like to say that we provide a comprehensive report for each assessment that we make. This report consists of 3 main parts, and they are general information about the application quality, a summary of all found issues, and a detailed description of each found issue with recommendations. On this slide, we can see the first part of this report with general information about the source code quality assessment. I would like to highlight that a 5-point scale is used to unify the results and obtain summary assessments. The obtained values are translated into the letter indexes and given color identifications. The highest grade A means that there is no technical debt or its component in the parameter. The lowest E highlights a presence of critical problems that need to be eliminated before any further work on the product can be done. In the same way, we provide an assessment for all other dimensions using the corresponding metrics and techniques. The results of these measurements give the opportunity to calculate the technical debt both for the entire software product and for its individual parameters. And now, advantages of the approach. This assessment becomes useful not only for developers, but also for all stakeholders, and allows them to determine the direction of the product development. For example, developers and designers receive an independent third-party assessment of code quality and project coherence. Managers get the feedback on product overall capacity and therefore identify bottlenecks that prevent the development of the project in the future. Product owners can assess the effectiveness of allocating funds to development team and determine priorities in product development or the need to postpone certain plans until the technical debt is eliminated. Investors receive an additional measurable argument to invest in the product. Such an in-depth analysis of the product tells companies whether the product is ready for the market launch or not. And there are some limitations of this approach. First of all, the expansion of the concept of technical debt beyond the code quality increases the role of subjective assessment and excludes the possibility of complete automation of the process. Then evaluation using the Tetra approach allows to identify the technical debt in different areas, but doesn't give a direct answer about the methods of its minimization. For this, it's necessary a further investigation of the causes of the problems. And finally, the technical debt minimization requires such assessment on a regular basis that depends on the size or condition of the project and the available resources. Next, I am going to show you an example of project assessment using this approach. Our client was an educational and technology company that decided to update its e-learning platform and to increase its user base. The company decided to assess the platform's current technical capabilities before updating the platform and adding new features. The project consisting of about 120,000 lines of code, different modules, and was developed by a team of 5 developers and 2 quality assurance engineers that spent more than 2 years working on it. This slide shows the summary assessment results for each dimension and for the entire project as well. The final assessment is represented as a table with numbers and indexes for each metric reviewed. As I mentioned before, a 5-point scale is used to unify the results and update summary assessments, both for each dimension and for the product. So here we can see the results for source code assessment, usability, security, performance, business logic, architecture, data quality, and open source code use. The strongest part of Tetra methodology is the possibility to introduce indexes instead of exact numbers and carry out further investigation based on the analysis of these indexes, which are metric index, dimension index, and overall tetra index. The final assessment calculation of the product quality is made using a system of weighting parameters that define the role of each dimension in the final assessment score. As we saw on the previous slide, the final report demonstrated the overall system state as medium. At the same time, a detailed analysis of the results showed that with a positive overall assessment, there are some issues that can lead to software crashes in the future after updating of the functionality. The elimination of these issues allowed the project team to avoid significant cost for fixes and reworking of modules when developing the next version of the platform. So the important thing about the applied Tetra approach is that its results are not merely for technology experts. Developers, testers, and managers get the comprehensive assessment of their work. Users get a reliable and well-performing product. And moreover, the processes used for the product assessment train the team to follow best practices during the product development. This increases team proficiency and consequently the quality of the product. And thank you. That concludes my presentation. If there are any questions, I will be glad to answer them.
Right. Thank you very much. This is quite interesting. Are there any questions? Any questions? Okay, I've got a quick one. There's something I'd like to understand. Can you apply Tetra as the system is being implemented? Like, blending it with your unit test and behavioral tests to the system. Will that make sense?
Yes, of course. The main purpose of Tetra is to quantity evaluate the whole product. And one of the components of the Tetra is the code quality assessment. And it provides the possibility to analyze code quality assessment where unit tests and different parameters of code as well. Do I answer your questions, or maybe?
Yeah. So in the process of implement, so as part of the process, we can just plug in Tetra, and as you get your feedback from your testing, you also get your feedback from Tetra to improve on the design already during the implementation process. Is that what you're saying?
Yes, concerning the code, we use Sonar Cube tool and additional plugins that help us to cover different problems with code, because we use not only possibilities that introduced in source code, in Sonar, but we use our own plugins that extend this possibility.
Okay, thank you. Are there any further questions in the room? Okay. If there's no question, then we'll move to the next paper, low-cost embedded system for customer loyalty by Rui Duarte. Rui, are you there? Can you please share your screen?
Yeah, sure. I will share it.
Okay.
Okay. Can you all see the screen?
Yes, I can see.
Yeah. Okay, so let me start. Good morning to you all from Portugal. Greetings. I'm Rui Duarte, as Jose said, and I'm here to present the work of Mauro Lima. He's a PhD student in our research group. The research group is a research center in digital services, and we work on human factors and intelligent systems. Our base approach in this group is try to solve real life and real needs and use technology and science to come out with a solution, not only with research, but also with a solution for specific needs of different entities. So to have a low-cost embedded system for customer loyalty, we try to understand first what is the motivation of the participants in this context, and we have to. We have two types of participants, which are customers and stores. I mean, when we enter a retail store or a shopping center, for example, the biggest motivation for clients is to buy products, and the biggest motivation for stores is to increase their sales. So we need to create a win-win situation and use technology as a means to have targeted marketing from the stores to customers. If we can do this, this is our major motivation in this project. If we can do this, then we have a closer relation between these two participants. So after the motivation, we have, of course, we had to identify all the algorithms and technologies that were available and where work was being developed. And after identifying all the major algorithms for indoor location and positioning of people, we also try to understand which are the indoor technologies and try to understand which is the more adequate solution to solve our problem. So we raised the following questions. If we can add a different layer of knowledge for retail stores, for them to understand how they can interact better with customers, if they can attract more customers to their store, how do they attract more customers to their stores? And also, how can they increase their sales? Moreover, in the other part, we as customers have products of interest. So how can we give them products of interest in real time when they are inside the shopping center, for example? After these questions were raised, we tried to identify the most important constraints that we have in the implementation of this project. And one of them has to do with indoor location and the distance between a customer that is represented, of course, by a cell phone or a mobile application that's giving this position indoor, and a beacon that represents the store. And in theory, this distance function is not yet very accurate. So one person can be at 10 meters from a store, and in fact, she is at 20 meters from that store. Moreover, if we think about shopping centers, we think about a navigation, a plan which is very complex. And if every shopping center would have its own navigation and its own plan, then it would be kind of difficult to implement such a solution. So we need to have a plan-free navigation method. From here, we have idealized our general idea where we have stores or shops, represent shop 1, 2, 3, 4, 5, and we have a customer that's navigating inside the system. This customer with this mobile app and this cell phone, which communicates to a database, will be providing information and obtaining information regarding the positioning of stores and information that's being contained inside each store. So the major concepts we have defined were, first of all, we need to configure beacons in each store and define which promotions are available in a retail store, and it's stored in a database. Therefore, each beacon is in its own positioning will have not only his information where he is, but also he will transmit more information to the database, and retail store owners can provide promotions or other aspects that they want to define for customers. Then we look at the customer side. The customer with a mobile application sends his position and personal interests to the database. He defines his own interest. And if there is any match, then it will be returned from the database, which beacons and nearby beacons are giving the feedback about the interest that the customer has. And then the user starts to navigate inside a coverage area, and notifications about beacons are provided to the customer. And if there is a relation, if the customer is approaching shop 1 and shop 1 has interest that the customer has defined, then he will be notified of promotions from that store. This increases the proximity of stores to customers. Okay, so based on this idea, we had two problems to solve and to implement. One of them is the user beacon communication model. So how do I communicate with a beacon? First, we need to determine the distance that the beacon is related to the customer itself. And we get all the nearby beacons, or in this case, nearby stores that we have. And after that, the nearest one is the one that we will receive notifications or not if they are defined in the database and if they match our interest. So here we try to solve our first problem, that is distance function. We need to have some level of accuracy for the customer to understand if in fact he is near a specific store, or if the system tells him, okay, you are near a store, but in fact he's not near that store, he's still far away from the store. So we have created an improvement on the distance relation, which is given by 1. This is the standard equation that's used for the distance. And we had an average of coefficients. So in the configuration of beacons, we create sample data that will give us an average of the locations. And then after, with this correcting factor, we have corrected the distance, which provided us results that will tell us, for example, the real distance. If I measure the real distance between a customer and the store, I have the black circle. And the previous equation, the one that's been used until now, is the gray one. And when we look at the improvement that was made in different measurements, we see that this correction factor places the customer near the store more than the previous distance function. And this is very important because now, and the tests show that after this corrected distance is implemented, in fact, the customer is near the store. Another problem that we had is how to navigate inside a retail store, a shopping center, which contains a lot of retail stores. So our approach here was like to use the concept of a campus. We could not make the upload of a plan of a shopping center. We could do it, but it would not be scalable because every shopping center would need to have uploaded its own plan. So we tried to think a bit different. We tried to think about how can we move and orient ourselves. And so we thought about the concept of campus. So we have a minimap that's designed, and after that, in that minimap, we have an arrow that's pointing towards the direction of where the store is. Then we determine the rotation angle. That store is represented by the beacon. We know the location of the beacon, and then the system will have to guide me to that store if I want to go there and buy some product, because I've been notified if there is a product somewhere that's of my interest, for example. So we determine the rotation angle of the gyroscope. So it has to be counterclockwise because we need to make that adjustment for it to work well. And then as I move, the beacon works as an attractor, and then the distance is being calculated, it's being adjusted, and I am at a store. So this is the two problems that we have solved. For example, for formulas and equations, please read the paper that we have submitted, and this is more graphical. But then we need to go further. We need to implement and test it in real life. So we decided to implement a mobile interface to test this system. And for the customer, he defines his own preferences. He sets up what he likes and what he wants to have notifications when inside the store. As he enters the system, then comes the communication model where he gets all the information about his preferences that are stored in beacons or related to beacons in the database. And then we have a lot of some of the stores that we can go to. As we click, we can go to a store. And for example, this is the part of marketing itself. So we can go to a store that's nearby and we say, oh, let me generate something that I can win, or a promotion that can be generated instead of given. And they give me, for example, a discount. And then I can go to the store, and then comes the navigation model in the enters. So as I'm moving, the beacon is working as an attractor, and the system is taking me to the store. When the distance is at 0, okay, I'm at the store, arrived, claim your prize, and then comes marketing. So we can claim our prize and exchange the coupon and come back home with a new bag in this case. So as a conclusion, we have made improvement on the distance function or equation that is to determine to reduce the margin of errors in proximity accuracy. We have implemented a plan free, it's intuitive and it's scalable for other shopping centers navigation system, and used also beacon technology for proximity marketing. It's centered in the customer and it allows the generation of coupons amongst others that are not present here. As future work, we look at this in two major directions. One of them is the three-dimensionality. It is only now it's implemented at the 2D in a 2D plane. So we need to include the Z coordinated for us to be able to move between floors. Moreover, and this is what Mauro is doing right now, we are using hybrid recommendation systems to generate promotions according to the customer profile, more targeted oriented based on the knowledge that we have already acquired from the results and from the testing that we are doing with the application and the physical application. Thank you all. And if you have any questions, please feel free to ask me.
All right, thank you very much. Are there any questions in the room?
Yeah.
Please go ahead.
Yeah, this is Stephen.
Stephen.
Yeah, there's a very nice presentation and good insight into aspect of customer relationship management. I want to find out how do you deal with all complexity presented in your slices relating to customer relationship management? Because if you look at CRM, CRM forms kind of an IS that looks complex, and looking at the architecture you presented on the slide 6, seems to me that there is a bit of complex communication in there in terms of the beacons and in the customer interest into the database and stuff like that. How do you deal with the complexities in relation to managing customer relation as far as this study is concerned?
Okay, if I understand, for example, one of the first parts is the beacon configuration of each store. It's not only to place them physically somewhere, it's just we need to set up more stuff. One of the things is to have them in a physical space, and the other thing is all the information that's probably, if I give this for follow-up. For example, this part 1, this is all done in a back office where each store has its own account, and they can configure not only the position of the beacon and do some of the tests that will improve the accuracy to the distance function, but also they can define promotions, or they can define which products they will have available, and they can generate different types of promotions that are oriented for customers. Promotions can be discounts, promotions can be of several types. You can exchange products also in the system for customers. So this is the first part, where all the beacons are configured in the database by using a back office. Then you have the part of the customer, where he defines what he likes, as a person what he likes. And this information is transmitted to the database, where we verify if stores have the preferences, have defined that they have products that are of the customer interest. For example, if he likes sports, then if any in the database, if any shop has information about sports or products related to sports, and if the user is near one of those shops, then he will be provided a notification for him to go there. But this is just one of the aspects. For example, if I enter a store, I can go to if I enter a shopping center, I can go to one of the, just to generate a coupon, I can click and generate. And then I can be guided to the store directly instead of having a coupon generation process. So this is transmitted back. So as I enter the space, if there are notifications for me as a person, that's a person of interest in that product, then when the customer is about 5 meters from that store, it will be notified again as you are arriving. If you want to use your product, please come in. And this is proximity marketing, and it's basically, this is bottom line of how it works. I don't know if I answered your question.
That's right. That's right. That's right. And I very much understood.
Okay.
I'm only thinking that if in future kind of an AI or kind of an intelligence system that will be developed to and making sure that the AI is correct. So what the system is expected to do, it should do it. I'm interested in that area of studying. That's why I'm asking about complexity.
This is what's being done here in this top part.
All right.
Generates
sure.
This part is not done, of course, because now we have the recommendation system being implemented. Okay. But we need to have data, and we need to have our own data to create such recommended hybrid recommendation systems. Yeah.
Okay. Thank you.
Thank you.
Right. Any other question? I've got one. I must say I've got a twisted view of your system as I was listening to you. How about having different stores form some kind of coalition? So now when the customers show up, how will that influence not the distance calculation, but the navigation of the system? So we've got promotions in our shops. Now we've ganged up, we form a coalition. How will that influence the whole execution of the navigation to the shops in the system? And will there be any way of reordering? I don't know if there's any order actually, but how will that influence the navigation of customers?
Okay, from what I understand in your question, if we have, for example, in this image, in the images I've shown, shop 3 stores that are working together instead of working alone, is kind of like that.
Yeah.
Or yeah, of course that this is dependent on a beacon. Okay, so the navigation works as where the beacon is the attractor to where I want to go to. I say I want to go to, if I have a notification of a store, I say I want to go to that store, and then a one-to-one relation starts between the navigation and the beacon. The user is taken with his mobile app to that store. Of course, that if we have stores in coalition working, it's not difficult, for example, to have a relation that if it's kind of like when you buy online and the product you may also want to buy. And this has to do with customer engagement with different contexts. And it's not difficult to implement that solution, because then the user, if he's notified in his application of another store that's, okay, you have bought a pair of shoes, so why don't you buy a jacket? And okay, I want to buy a jacket, then a one-to-one relation, and they are working together. And this is basically what's happening, not implemented, but basically it's what's happening. It's just solved in the user interface, this part.
Okay. Because I was thinking, you could imagine that, some shops within the center will be selling the same product. So they will be in competition for those products. And so once you have a coalition, those that are coalized, those that have formed the coalition will probably, even if they're using different beacons, they could appear as one single unit. I thought that it will change the way it's presented to the user.
No, it's not. There's no need to have a different presentation for the user, because okay, we have a problem with beacons because the coverage area of a beacon is not very far. It's 20 meters. So
yes.
For example, shop 7 or 8, that they are outside my range as a customer. So that could be a bottleneck if one store that's 50 meters apart from each other, for them to work together. We could use the Wi-Fi of the like we use for the information that the customer defines and he receives from the beacons. Well, it doesn't receive from the beacon because the beacon is just a beacon. It just says yes, no, I'm here, right? So this comes from the database. I think we could solve it through the database instead of solving it through the beacon itself.
Sorry, I must interrupt. We're behind on our schedule, so we have to close this, if that's okay.
All right. I was done anyway.
Yeah,
please go ahead.
It's all right. I sincerely thank all our authors today for their excellent presentation in this session, and to all our participants for being part of this integral Congress. I hope this session was informative and knowledgeable as well. Okay.
All right, thank you. Bye, everyone.
Just quickly. So all our presenters will be getting their digital certificates through the mail within 2 working days. Further, all the papers we have already forwarded to the Springer. The publication will be live within 46 months. Kindly cooperate with the team of ICICT as and when they ask you. Next, I'd like to thank our session chair, Jose, for chairing the session. A token of our appreciation on chair of behalf of the team ICICT 2021 and knowledgeable research. Thank you for your valuable presence, sir.
Thank you too.
Just quickly, I request all our participants to turn on their cameras for just a quick snapshot of the virtual conference, if that's okay. Thank you. I've got it all. Thank you.
Thank you, everyone.
Stay safe and take care. Thank you.
Thank you very much. Thank you.